So we have now what volume of the following acids will react with 50 milliliters of 0.2 molar sodium hydroxide. And they give us two acid solutions, a 0.1 molar HCl and a 0.15 molar nitric acid. The first thing we're going to do, because we're going to need it in both calculations, we're going to calculate how many moles of sodium hydroxide we're actually going to have to neutralize with both acids. So real quick here, the first thing we do, we have 50 milliliters. We have to change this to liters. Remember, from going from milliliters to liters, we're going to move the decimal point 3 spaces to the left. So that would give us a 0.05 liters. We're going to multiply that by the molarity because remember that for every 2 moles of sodium hydroxide, we have 1 liter of solution. So that gives us 0.01 mole of sodium hydroxide. Okay, so we're going to neutralize 0.01 moles of sodium hydroxide with HCl and with the nitric acid. Let's start with the HCl. Real quick, as usual, we're going to go ahead and do our equation. So sodium hydroxide reacting with HCl, you're going to form water, and sodium and chloride ions, we're going to put them as sodium chloride in here. Is the reaction balanced? That's one important question because we're going to do a calculation and we have to make sure that we have a balanced equation. All right, we're ready to do the calculation. We're going to start with the moles of sodium hydroxide. So we have 0.01 moles of sodium hydroxide. According to this equation, every mole of sodium hydroxide reacts with 1 mole of HCl. So it's a 1-to-1 reaction. 1 mole sodium hydroxide, 1 mole HCl. We make sure that we are canceling units to make sure. So now we have moles of hydrogen chloride, and we have a solution that's 0.01 molar. So we're going to use that. All right, we're done here. Our solution, our units cancel, and we need 0.01 liters of sodium hydroxide. If you want to give me the answer in milliliters, remember now we're converting liters to milliliters, so we're going to move the decimal point 3 spaces to the right. So that gives you 100 milliliters of your 0.1 molar solution of HCl. All right, the nitric acid. We're going to do exactly the same thing we did here, but we're going to do it with nitric acid. And as usual, I'm going to go ahead and start with my equation, nitric acid reacting with sodium hydroxide. It's a neutralization reaction. You always make water in an acid-base reaction. And your ions are going to be sodium and nitrate. So we're going to put sodium nitrate here. The calculation is almost going to be identical to this one. The only thing that changes is the molarity because we have 0.15 molar nitric acid. So we have 0.01 mole of sodium hydroxide. Notice the equation is balanced. It's still a 1-to-1 reaction, so 1 mole of sodium hydroxide reacting with 1 mole of nitric acid. The difference is that now I have a little bit more concentrated solution of the acid. This one is 0.15, so it's 0.15 moles of nitric acid every liter of nitric acid. I'm going to go ahead and always make sure that our units cancel. That's the easiest way for us to find the mistake. So we get 0.0667 liters of nitric acid. You can leave it like this, or you can convert it to milliliters. Remember to convert liters to milliliters. Move the decimal point 3 spaces, to the right. And that gives us 66.7 milliliters of nitric acid. Work some problems, more problems like this, because this is likely to be in your exam and it's likely to be in the quizzes that you're going to take.